This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This is episode 617, and we welcome Ehsan Mousavi of the Clemson University. Let's get this right, Department of Construction Science and Management. We're going to talk a little bit about indoor air quality and what we can learn from hospitals today. Before we get started, we want to thank our sponsors. Please let our sponsors know you appreciate their support of IAQ Radio Plus.
Our marquee sponsor is Instascope at instascope.co. Our association sponsors are the American Industrial Hygiene Association at AIHA.org, the American Conference of Governmental Industrial Hygienists at ACGIH.org, the Cleaning Industry Research Institute at CIRIScience.org, the Indoor Air Quality Association at IAQA.org, the Restoration Industry Association at restorationindustry.org, the Institute for Inspection, Cleaning, and Restoration Certification at IICRC.org, and Healthy Buildings America 2021 at HB2021-America.org. Industry sponsors are AEML Laboratories at AEMLinc.com, Particles Plus at particlesplus.com, Gray Wolf Sensing Solutions at graywolfsensing.com, TSI Inc. at tsi.com, and Healthy Indoors Magazine at healthyindoors.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick at cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. Congratulations go out to John Lapotere, Orlando, Florida, who was first to identify conduction, convection, and radiation as three ways that heat transfers from one object to another. The IQ Radio Trivia question for today, Friday, February 19, 2021, has been sponsored by TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigation business at tsi.com. Here is today's trivia question. In 1996, the CDC established a term broadening the focus of prevention, applying the principles to all patients regardless of diagnosis or presumed infection status, considering the risk of transmission of illness from both recognized and unrecognized sources. Name that term. Back to you, Joe.
All right, thanks, Cliff. Dr. Ehsan Mousavi is an assistant professor in the Department of Construction Science and Management at Clemson University. He got his Ph.D. from the University of Nebraska and did his undergrad work in Iran. And he has served in various capacities in the construction industry, including dam, road, and, of course, building construction projects. Currently, his research is to appraise the effect of environmental parameters of design, construction, operation, and maintenance of healthcare premises down at the Clemson University. Welcome to the show, Dr. Mousavi.
Thank you for having me, Joe. It's a pleasure.
My pleasure. Hey, it must have been a bit of a culture shock. So you went from Iran to Nebraska. How did that happen?
Yes, sir. What a journey. So, I guess I don't mean to take a lot of time talking about that, but it wasn't me who came here first. My father actually came here, and he graduated from Oklahoma State University back in the 70s. And then he got back to Iran to marry my mother, and then had me. And then 30, 40 years after, we decided to kind of follow the same path. So I started applying, and one thing led to another, and I found myself in Nebraska, Lincoln, Nebraska, in a beautiful yet cold spring. Well, was it spring? It probably was winter time or so. What we call in academia spring semester, right?
Yep.
That was the first cultural shock, right? It's just cold and snowy and all that kind of good stuff. But hey, I liked it. I survived. I enjoyed my time. Got a job at Clemson. I've been blessed.
How did you get involved in the hospital work? Did that happen when you got to Clemson, or were you doing that prior?
What a great question, Joe. So when I came to America, I came with a different agenda. So I was a project manager, a construction project manager for about like 8-9 years or so. So I wasn't a typical student who finishes a master's degree and right after starts a PhD. There was a gap of about 8 or 9 years between the two degrees. So I started working in various capacities in the world of construction, and questions built up, right? How do I do this right? How do I do that right? And at some point, I was like, I need to find good answers for these questions. And that was my time to decide that I need to do a PhD. I need to learn more. I need to be a better man. And I gotta tell you guys that my wife had a really outstanding role in that. She was always supportive, always supportive. And then I came to the States with that agenda in mind. How can I be a more efficient construction manager? Then all of a sudden, I got acquainted with another topic, right? At the time, it was a little weird because there was a professor, my advisor, Kevin Groskoff at University of Nebraska, who was doing things on hospital IAQ and things like that. And in our first meeting, and I'm not gonna lie to you guys, first meeting was like, what's going on? I was looking around. Am I in the right department? Is it because the terminology was all weird? I mean, there is a lot of medical terms, like your trivial question terms and things like that. And I'm like, well, let's actually put it in some context. I'm not speaking English. That's not my mother tongue. So I'm like, what is going on here? So I got my head spinning several times, and then I started reading, and I asked for 2 weeks of time from my advisor. I said, well, let me just read. So I read and came back with 2 pages of questions. And I'm like, man, this is right on. This is much more fun than I thought. This is probably more relevant, probably much more needed than my agenda. So I'm ready to switch trains. That's what I'm going to do. So I started actually reading more, doing experiments, tests in actual hospital system. And at the same time, I started to learn and get better on the mathematical fundamentals, like air movement studies, CFD computational models, statistical models, and things like that. Try to kind of, create a well-rounded type of research. And that was all the beginning. So we had a lot of experiments in hospital systems. And I started learning more and more about how air actually moves in indoor environments, how contamination spreads, how can I model them, how can I learn more about them. And that was my PhD work, like all together. When I came to Clemson, again, well, if you think about it, what I did was not a traditional research in construction science and management.
Okay.
But I stood by it. And I'm like, well, this is needed, this is relevant, and this is all pre-COVID. So you all know what I'm talking about. It was about the time that, folks didn't, should I say, take it seriously? Probably something along those lines, but I still thought there's a lot to do about this, and just, stood by it. That's my agenda at Clemson. I'm working with organizations that around the world, actually, that are within the same realm of research. I am with ASHRAE, Actually, I'm going to be a voting member with ASHRAE 96, which is ventilation for healthcare facilities. And I'm with ASHI, and I just continue work on this.
Well, you also have interest in energy in hospitals, and hospitals are big energy. I mean, they're pigs, all right. They really use a lot of energy. Where do you see the biggest potential for energy savings in your work with hospitals?
What a great question, Joe. So if you look at the data that's out there, you can find that energy consumption of a hospital, about 2/3 of that energy goes towards mechanical HVAC system. And then you've got other things like lighting, hospitals, let's keep in mind, there's a lot of equipment and technology that's going on there that all needs, energy and so forth. But again, a big chunk of all that is the mechanical system. And there was, the data shows that a hospital spends about 5 times the energy of an equivalent commercial setting. Which is, again, huge. So if you ask me, I guess I got a dog in this game, but if you ask me, mechanical systems, HVAC systems, air distribution systems are our best bet if you want to save energy in a hospital setting. Okay. Now, if I may also add, and I'll be quick about this, through time, the reason why we need a lot of air into our hospital settings have changed. Back in the days, you had these huge MRI machines and things like that. They were a source of heat. So you needed to deal with that heat, and you need a lot of, energy. Right now, we actually found our way to be much more efficient about energy consumption on the equipment side, which means that we cut the heating load from a hospital, but there's a lot of residue that's coming in. And now air quality becomes an issue. Yet we're spending a lot of energy, somewhat regardless of what's happening out in the technology that's being used in hospitals.
And a lot of it's because of ventilation needs, and then negatively pressurizing rooms, exhausting to the outside, 100% outdoor air in some of these areas. So there's obviously a lot of room for improvement. When you look at doing renovation in hospitals, it's obviously tough, if not impossible, to shut down operations. And you did some research on the use of what's called a control cube. And I forgot to get John to get that picture up. But John, maybe you could go to, if you could pull up a control cube photo. I'd like to talk a little bit about your research you did on the use of control cube for inspection and maintenance activities. Is this something that they were already using in the hospital, and you were just trying to verify whether it was working or not?
Yes. So I am working with a group here called Prisma Health. They're one of the largest healthcare systems in South Carolina, and we have a very fruitful sort of relationship with them as far as doing research. They have been always gracious about letting us in their systems and facilities and having us use what they have. One of the things they actually were super excited to know more about was this control cube that you're showing. Obviously, the technology has advanced in a sense that now you have control cubes that are stainless steel. They're larger. And the capacity, the height can change and be adjusted. The size can be adjusted depending on the scope of your repair. And they're also equipped with some fan and some HEPA filtration system, right? And the question was this: are these things really useful, right? And then we went in and started to test this. So we started to come up with scenarios and formats like simulations where, what happens if, a construction worker wants to remove a ceiling tile and do some inspection on that ceiling, check the wires, do XYZ, whatever the case may be. And guess what? That's going to release a lot of dust and potentially pathogens attached to the dust into the space. And that's certainly unwanted, right? One way about it is to set up that control cube right underneath of your scope of work for that repair. And you can actually adjust the height and press it up on the seating side. So it's all nicely, relatively nicely sealed. And then do what you're supposed to do. And the question was, is this an effective tool, right? So we did that, we tested it. We actually had a scenario where there was no control cube. We started to simulate whatever the case was, moving the tile and so forth. That we had a strict scenario for all of our tests, just to make sure that that's not a confounding variable in our work. And then we measured the counts of particles and dust in 3-4 places underneath that tile and in the vicinity of it, surrounding of it, right? And then we set up our control cube, did the same thing. And it turns out that it's very efficient and very effective because it essentially contains the dust at the source. Now I have a caveat to share with you guys. And the caveat is that the efficiency of those cubes in our research are dependent of the door kept shut. Mm-hmm. So if the door of that control cube is open, what's the point, right?
Right.
Now, another thing that was super interesting in our work, because we repeated our test many times, is when you open and close the door, and you do it frequently, the efficiency goes down pretty dramatically, meaning that particles can migrate in and escape from that control cube environment and go elsewhere, right? Now, the good thing is that we also tested the HEPA filter, and well, it's probably no brainer and we expect that, but 0 particles at the HEPA filter. So the filter works pretty good and pretty reliable. What's really important is for the user, for the construction worker, to understand that they don't want to close that door quite frequently. If they need tools inside the control cube, let's actually take them with us. And let's do the job, wait there until the inside space is cleaned by the HEPA filter, and then leave.
I think that's a key point you just made, though. They can't just leave right away. They've got to wait a minute and let that negative pressure build up, let it clean the air. That's a good point.
Absolutely. And if I want to give you a number, because we also tested that, for a control cube, the size that we did, I want to say it was about, I can actually check it. It was about 2.5 feet by 4.5 feet, the size of that control cube. Our tests essentially show that you probably want to stay inside for 2 minutes.
2 minutes, okay.
Depending on the CFM of that HEPA filter, obviously, right?
Right.
Depending on how fast the air is turned inside the cube. But yeah, well, for a typical control cube that's commercial, that's out there, and assuming that you set it on high, yeah, you want 2-3 minutes, stay there. Let's not leave. Let's actually get the dust settled and filter out, and then you should be okay to leave.
Okay. Cliff, you have a follow-up?
I do. It looks like a phenomenal tool. I've seen them before and always felt that they would make a lot of sense. I guess what my question is there not a risk when someone comes out of it that their clothing is contaminated? So is the person inside the cube, wearing Tyvek or something like that he could actually take off, once the air cleaned? Because it seems that, you could kind of burp out, excuse the word, a bunch of contamination, once it was unzipped, or perhaps maybe even wheel that person to, to some area in the hospital, where they could take it off. I never realized how much particles were generated during the removal of the equipment, the doffing of it.
Great point, Cliff. And let me add to that here is a key finding from our work, that when that person opens the door without waiting, right, and then leave the cube, the dust that you observed outside of that control cube went up 10 times. That's a huge number. Like if it was 500, it becomes 5,000. If it was 10,000, it becomes 100,000, right? So that's risk. Although it's a point measurement and you can actually see that it quickly drops down, right? But still what happens is that during that early time, exactly what you just said will happen. In the control cube, in my observation experience, there's usually not enough space for them to dawn on and off. So it would be a bit, at least it's not what they do. However, I ran into this quite creative project manager, again, up in Prisma Health here in Greenville, South Carolina, where essentially they had a vacuum cleaner type thingy. They brought it with them inside and they vacuumed themselves. And then they actually stepped out. I got to tell you, in our research, we did not test that scenario. I wish we did, but we didn't test that scenario. But my point being, with the proper training and creativity, there are ways for us to minimize that risk.
Well, it would also seem that, perhaps they could spray themselves with something. It could be detergent water, just water, mended water, that they use for asbestos or whatever, and it would probably help some of it anyway.
Absolutely.
And a lot of times they may have a HEPA vacuum with them as well because of what they're doing above. So they could use that as well. The other question I had for you on that particular study was, did you look at using the control cube without the air filtration device being on, and if that helped at all?
A lot. Yes, we did. And the finding is day and night. If you ask me, it's, well, if you recall, I said something within the lines that if you have the cube and you don't have the cube, you're looking at an order of magnitude increase. So if the established background, let's say, is 1,000, you don't have a cube, it goes up to 100,000. But the control cube can keep it actually at least an order of magnitude lower, right? Okay. HEPA on, HEPA off doesn't give you that much of mitigation, but it easily gives you about 30 to 40%.
Okay.
If that makes sense. So which is, again, a lot when it comes to risk mitigation.
Sure.
So yes, absolutely. And that was a big point, because another effect that HEPA filter can have is that it obviously creates a negative air pressurization inside your cube. Now the door is also more effective. Now migration and escape of particles is kind of going down, which is another plus.
But it may also pull particles from that ceiling plenum when you turn that machine on. So very interesting. Whether or not you want that machine on or not, I think could vary. That's something that I think in the future maybe we'd look at a little more closely.
Yeah, well, yeah, you're right. Maybe again, I wish our test scenarios could answer specifically that question. But one thing that can happen is that when you remove when you generate aerosols, let's keep it shut down. When you're done, let's crank it up.
Turn it on.
Or something like that.
Okay. All right, let's go to, I want to talk a little bit about your training of renovation workers and some training tips. So if people are doing work in a hospital, they're performing renovations, what kind of tips can you give us for training these people that are going in and doing this type of work?
Joe, where do I begin? Well, let me share the biggest takeaway, my biggest takeaway from that work. And here is the idea. When I was talking, so let me talk less than 30 seconds about what we actually did.
Okay.
So we identified the largest healthcare contractors in the nation, the top 15, and asked them to help us frame and understand what's going on, what's different from healthcare construction and other sorts of construction. I think 10 out of 15 participated. And from each group, we had somewhere close to like 10, 15 different project managers across the nation who helped us with that. Here's my biggest takeaway. When it comes to training for project managers, for the upper level managerial folks, probably hospital safety managers, hospital personnel, you get good stuff out there. I mean, ASHRAE is a great resource for that, for example. And they've got a lot of systems going on. They actually keep you up to date with the trainings and so forth. Now, in my opinion, the issue is the frontline workers who actually do the job. They don't necessarily get training. And even if they get training, even if the hospital systems, because that's case by case now, right? Even if the hospital system wants to set up some training for them, they get bored pretty easily because they feel like, well, why do I even need to know all this? The type of training they receive is somewhat traditional, which is less entertaining, if that makes sense. So my biggest takeaway was we need to do something about subcontractors and general contractors, workers who actually do the job. They need to know more about this. And now we live in a world of technology. So if need be, we can use a goggle and essentially show them, well, if you sand a piece of drywall here, this is how much dust you generate, right? And they can literally see. That's what I do. I make those models, right, to show them what's going on, how these little things spread in the space. What does that negative pressure now mean? Like visually, you can visually see that with the negative pressure, particles don't go out, right? This to me is effective training, and I wish all of us together can create that momentum and move towards that direction. That would be super, super cool.
Hey, I got a text question from the last topic real quick. Were your measurements done with real-time particle counter? And if you want to mention what type, that's fine.
Yes, sir. Yes, sir. So pretty much everything I have done, I'm trying to think, I want to be accurate when I say everything, but I think I am, is real-time time series particle measurement. Because I'm a true believer that those real-time values, time-dependent values matter, right? And that's sort of as opposed to some passive measurement systems like bacterial count, bacterial load measurement systems, where you have a settle plate in a space, for instance, and it sits for the duration of your test and you get one data point in time. Oh, that's also quite awesome for different purposes. What I'm most interested in is essentially time series of data, how concentration changes with time, because only then I can define new scenarios and test them. And to answer your second question, we use, well, one of your sponsors, TSI, they have great measurement tools. We use them, and some other competition systems and teams. We have a in-house researcher here at Clemson University who has developed a low-cost particle counter. And we're working together to make those also available for the types of tests that I do. But at the moment, it's limited. What that system or what that instrument does is limited to PM 2.5. Again, depending on my type of study, I want submicron particles be counted as well. So we're not there yet to use what we have in-house, but we're doing comparisons. As
Cliff, you have a follow-up, Cliff?
I did. I just wanted to comment on something that Ehsan said in dealing with with some of the frontline workers that traditional training methods such as lecture and slides and stuff like that really may not resonate with them. And also you're going to encounter workers who English may not be their first language either. And in having to do some of this type of training earlier in my career, one of the things that I found in terms of the training, particularly for people whose English, for whom English was not their first language, is I could kind of break it down into 4 words, and I could tell it to them in their language. And the 4 words that I needed to know was that clean was good and that dust was bad. And that was really the concept that, that they needed to know. Clean's good, dust is bad. And also to use things that they could see, visual things, such as smoke or something like that, that they could actually see it, because you're talking about particles and they can't visualize it. However, if you can use a small smoke generator or something like that, they can see it, and it makes it a whole lot better, with air flows and so on and so forth. So those are just a couple suggestions for you there.
All right, we're going to stop here. Thank our sponsors. When we come back, I want to talk about this paper, Performance Analysis of Portable HEPA Filters and Temporary Plastic Antirooms. I think that's, on the spread of surrogate coronavirus. I think there's a lot of good information in that one. We'll be back in 2 minutes with our guest, Dr. Ehsan Mousavi.
Our marquee sponsor, Instascope. More jobs done faster with the future of IAQ assessment technology. Unlimited samples, instant results, and cloud-based data at instascope.co. Our association sponsors are AIHA, Healthy Workplaces, A Healthier World at AIHA.org. ACGIH, Advancing Careers of Professionals in Environmental Health, Industrial Hygiene, and Safety, interested in defining their science at acgih.org. The Cleaning Industry Research Institute. See more deeply through science and research at ciriscience.org. The Indoor Air Quality Association, promoting the exchange of indoor environmental quality information through education and research at IAQA.org. The Restoration Industry Association, the granddaddy of the restoration industry, network with leaders at restorationindustry.org.
The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry at iicrc.org.
And Healthy Buildings America 2021 in Honolulu, Hawaii, August 10 through 12, 2021 at hb2021-america.org. IAQ Radio industry sponsors are AEML Laboratories, free shipping, great pricing, same-day results with no rush fee at aemlinc.com. Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us at particlesplus.com. Gray Wolf Sensing Solutions, over 20 years manufacturing accurate, reliable IAQ instrumentation for portable, short-term, and continuous monitoring at graywolfsensing.com. TSI Inc., an industry leader in precision instrumentation for monitoring indoor air. Learn how to expand your IAQ investigations at tsi.com. And Healthy Indoors Magazine, a free online magazine for industry professionals and consumers at healthyindoors.com.
All right, we're back for the second half of our interview. We've got Dr. Ehsan Mousavi, and we're going to talk a little bit about a paper on the performance analysis of portable HEPA filters and temporary plastic antirooms. John, can you pull that up? Let's set this first by, I was a little thrown by the title because it had antirooms in there. And I was like, well, wait, I thought the antiroom was a room on the outside of a room, but it looks like you kind of built an antiroom within a room here. Is that accurate to say?
Yes. By design, you're absolutely correct, Joe. So if we design an antiroom from, at the design stage, then we want to design it towards the outer side of our room, and it's sort of on the outside of the entrance. In this case, we actually had a room, and we wanted to check and see if we can create something that would help us better and the healthcare workers better when they deal with a COVID patient, right? Sometimes you can actually stick that in a room and build it on the outside, like in the hallway that
Yes.
you can see on the picture where it says door. Depending on the width of that hallway, sometimes it's not possible.
Yeah.
Right. And sometimes it makes it super hard to do something like that. So we thought that why don't we use the space that we have inside and test that and see what happens? Because if that's proven effective, it's not too hard to create a plastic barrier like you see in the image. And then maybe that's something we want to consider when dealing with a COVID patient.
So essentially, you took this room and divided it not quite in half. It looks like you got more like, 2/3 for the patient area, and then another area that would kind of be the entry exit, sort of like a decontamination unit that we see on remediation projects. You've got two HEPA air filtration devices, one in the patient room, one in the ante room, and you were testing to see how well that worked. Is that accurate to say?
Yes, sir. And if I want to quickly add, when we were testing, we actually released particles, oil-based particles, assuming that a COVID patient is lying down on that patient bed. And we did measurements inside that isolation space, within that anteroom space, outside of the room, at the door, and down the hallway, to see how potentially those particles can spread within the space.
Okay. And let me ask this, as far as the exhaust of your air filtration devices, it looks like, at least in the photo, you were going above. Is that a suspended ceiling, or were you using a return air, or are you going directly to the outside? Could you explain a little for listeners how you did that?
Sure. No, for this experimental setting, we actually, the exhaust location was high, not from the ceiling, but high in the wall, but out of the room. So on the left-hand side of that testing section, where you essentially don't see it in the drawings, there was another hallway.
Okay.
So the exhaust actually went into that hallway.
And that you were able to do that because this was just an experiment. It was an empty area, and even if something got past your HEPA filter, it wouldn't be a big deal.
Correct.
And I guess there's times when, especially today with these hospitals being just challenged immensely, I wouldn't be surprised if they were exhausting into other areas right from the air filtration device, just, assuming or hoping that HEPA filter was capturing everything. But typically we're going to try and exhaust that to the outdoors. So can you tell listeners a little bit about, and the other thing I wanted to ask is this, you want that, where the HEPA 1, that part of the room, to be negatively pressurized to the HEPA 2 area, which is also negatively pressurized to the hallway. And I would imagine you had to do some adjustment to get that to work, because, you've got basically one area that needs to be negative to another, and then that area needs to be negative to a hallway, but the first area needs to be negative to the first area. So it seems like you probably had to adjust the amount of CFM on the HEPA filter or on the air filtration devices to get that. Is that accurate to say?
Yes, sir. That we did. We did. And so the HEPA machines, they essentially had two modes, low and high. right? And so we didn't actually have a lot of wiggle room when it came to setting up that pressure. But say, for instance, if you wanted the isolation space to be negative with respect to anteroom and anteroom be negative with respect to door, that was achieved by high-low, if that makes sense.
Sure. So you had the one in the isolation room on high and the one in the anteroom on low.
Correct.
Okay.
And the good thing about it was that we also tested a case where HEPA 1 in that figure was off and HEPA 2 was on, to see what happens if you have a negative pressure from the rest of the space, but anteroom is kind of the dump of the particles, if that makes sense. So it's negative with respect to both spaces.
And tell us how that came up.
Oh, okay. So we tested. We did a lot of measurements, first of all, on pressurization across both doors. Now, remember, we had one door that connects isolation to anti space, and then we had another door, a hinge door, that will connect the anti space to the outside, the adjacent hallway. So we actually measured pressure at both stations. We also had cases where both HEPA filters were on, one was on, one was off, so forth and so on. Now, again, if I want to stay in 2,000 feet level and just kind of give you the big picture finding, rather obviously, if you have both HEPA filters working, you get a great result, right? So it's about cleaning that space so rapidly in both spaces. So that's your best choice. In the event that you only have one HEPA filter available, which is likely, right?
Yeah.
Then definitely do not put it in the anteroom and put it in the isolation space.
Okay.
Putting one HEPA filter in the anteroom, although it creates a better negative pressure across that hinge door, but overall is not a good idea because it draws pathogens and surrogate particles from the isolation space into the anteroom and creates a higher opportunity for those surrogate pathogens to leave the space.
And I think it would be, going back to what we were talking about earlier, you're trying to train people to do this. And the more complexity you add by having two HEPA units and different negative pressure differentials between these rooms, that would be difficult. But I'm wondering if you recall off the top of your head, what was your negative pressure in your isolation room compared to, and I assume you measured it both to the hallway and to the anteroom?
Correct. I want to say that depending on the cases, for example, in the on cases, what I call it, when both of them were on.
Yes.
So the negative pressure across that door was negative 12 Pascal.
Okay.
Which is what, like 5 times the current standard, unless, current ASHRAE standard, let me be clear, because FGI is changing that value. And then the other pressure was negative 4.
4 Pascal.
Yes.
Okay, interesting. And what I think when we talked about this earlier, one of the things you found during the study was the importance of that plastic doorway. And I wonder if you could talk to our audience a little bit about what you learned with respect to that plastic doorway and how important certain activities are when it comes to the doorway.
Excellent question, Joe. Let me start with the less trivial finding, which was that maybe less trivial to me, that plastic barrier in itself, and forget about the HEPA filter, is very, very efficient. And it actually caught me by surprise, because the moment you put that plastic barrier and you contain the bad stuff, the pathogens and the surrogate particles within the isolation space only with some physical barrier and with essentially no air barrier, you still get outstanding result. Obviously, when you add the HEPA, you get much better results, right? But I want to emphasize that the plastic barrier itself is a good idea. Now, in the absence of additional equipment, that can help us a lot. So that was the first thing I was going to say. And the second thing I was going to say is that during our testing, we also went ahead and created dents and wears and tears and, half open zipper and things like that. Less than perfect scenarios for that door. And the finding, which was also really, really good and outstanding, was that if your HEPA is on inside your isolation room, those little tears and, maybe a half open zipper and things like that, they won't actually hurt you so badly. Their effect, their effect is rather minimal. It's not too huge, right? You still see blips of, migration of particles into the ante room, but compared to the overall scheme, it wasn't super bad. And we actually, as part of the test, we created so we turned down a piece of that plastic barrier, turned it open, and placed the particle counter literally next to that opening, next to that hole, and then turned on the HEPA inside the isolation room, and you still get little particles migrating from that space, even though doing that, which was quite good. So that pressurization is pretty efficient.
And was that when both units were running or just one?
That was for just one unit running inside the isolation space.
In the ISO area. Okay. Correct. And did you do the same kind of thing at the doorway between the ante room and the hallway?
As to
whether or not opening and closing the door on the ante room, the plastic door, did that affect how much particulate got out of the ante room and into the hallway?
That is, yes, we did that, and the result is a negligible increase at the I call that measurement station, door measurement station, which is right outside of the room in that corridor. Very negligible increase in that door and in that hallway stations, measurement stations.
Gotcha.
Right. And Joe, if I may, I was going to also say one thing real quickly, and that is, after doing so many tests, and in my humble opinion, when we're talking about pressurization and we're talking about filtration, although they're somewhat interconnected, but we're talking about two different things. And let me give you an example to make it clearer. Let's say that you have a HEPA unit in a given space, right? And then the exhaust is directly to the outside environment. So when that thing is on, you expect to get a negative pressure, correct? Now, yes. So with that scenario, if one actually reaches to the ceiling sides and then drills a hole in the ceiling, you can see that pressure across the door vanishes when you create more leakage in your envelope, in your boundaries. However, the HEPA filter still works and it still cleans the inside environment.
That's a good point. That's a very good point.
Two different things. We don't want to mix them up. Again, they're related, but fundamentally do two different things. In my opinion, pressurization is important, but we don't want to get carried away by the magnitude, like 30 pascals or 20 pascals or those big numbers. First of all, achieving them is extremely hard because spaces can be leaky. and then they're not going to add a lot of value over, some given point. What's very important at the same time is to keep the space clean. And that's what the filtration system does, rather independently from creating or maintaining that negative pressure, if I make sense.
Interesting point. Yes, very good. Cliff?
Yeah, I did. Doctor, something I thought about when you talked about putting up the plastic barrier and that it was surprisingly effective. And I'm wondering whether or not you notice that sometimes when you put up plastic, what happens is it maintains the static attraction, and it actually attracts and holds dust. And I was wondering whether that was something that you had measured or something that you had noticed in your study.
What a great point, Cliff. No, we did not make clear measurements on that. Unfortunately not, but that's a very good point. I want to test that at some point. Hopefully, again, if the time and money are right, that is something I definitely want to look at.
But one thing you could do easy is if you took a dryer sheet from, clothes dryer, those dryer sheets, they're positively charged and they reduce static. So you could potentially, have one piece that was, you wipe the static off of, and you could allow other pieces to have the static and see if there was a measurable difference.
Right. And that is doable. That is something that we can, experimentally set up. Mm-hmm. Thank you for that suggestion.
You're welcome. You're very welcome.
Let me get one more question in here before we go to what we call our roundup. I want to see if we can bring in the restoration industry global watchdog. But before we do, you also have looked at how the movement of humans and the opening and closing of doors affects the particulate control and pressurization. I just wanted to give you an opportunity. We won't be able to go into great detail on the work you did, but what are the overall findings of your work with respect to human movement and opening and closing of doors? And I think one you're not done with quite yet, so understood.
Let me begin with the door opening, Joe. Door opening can terminate negative pressures up to 8 Pascal. And I say easily. Door openings can reverse pressurization up to 3 Pascal. Meaning especially depending on depending on whether the door opens towards that mainstream of air, towards the negative space, or against it, right? And door opening can actually reverse negative pressures for the time of opening, correct? So let's say that a typical opening is like 5-6 seconds or so for someone to open the door, step out, and then close the door behind them or something like that. With that given time, door opening can even reverse pressurization. And almost in every test that we've done, we see spikes of measurements associated with door openings. That's definitely a big concern that one can have. And now anti-rooms can come to rescue, especially if you have them by design. Right. Now, about human movement, what we did, and I'll try to be very quick about it, is that I went to the University of California at Berkeley for a project funded by the National Science Foundation. Mm-hmm. And what they did out there, and this wasn't a part of my project. I was just fortunate that the timing worked perfectly for me. But they were actually in-house building what we call a 3D air velocity measurements device. And you guys probably know that what we have right now that's commercially available out there, there are air anemometers. They measure speed of air, not velocity. And the difference is in the direction, right? So when you measure a speed, you don't know which direction that speed is. You measure magnitude of velocity. But the device that they created, that they came up with, it has not been commercialized just yet, is that that device helps you measure the velocity of air and the components, like the X component, the Y component, the Z component, and all that kind of good stuff. And again, if I want to give you one takeaway about that paper, human movement, although when we walk in a XY direction, right? We walk in a horizontal pattern. We don't jump up and down. But the Z component of airspeed, which is responsible for resuspension of particles, is huge. It's super big. It surprised me. So you're talking. So if the X component, meaning that the component that is along your motion, if that is 1 meters per second, that can create up to 0.3, 0.5 meters per second of upward velocity in the air.
Interesting.
Which was a lot.
And you didn't expect to see that, I'll bet. They didn't expect to see that.
No. And well, the beauty of that device, again, was that it allows us to do measurements in the Z direction. So we could literally see that, oh, there's a spike in the Z direction. When a person walks like this, air can go up and down.
Never would have thought about that. Interesting. Very interesting. All right, let's go to our roundup. Oh, by the way, I wanted to mention one more thing on the door opening and closing. Again, it goes back to the earlier discussion on training of people doing this type of work. It's something I've always focused on real heavy in our mold and asbestos training and so on. When you go in and out of that containment, how important it is for them to put those flaps back the right way and to do it quickly. And you've just confirmed that with your work, and I appreciate that. Let's go to the roundup, John. All right, let's go to the restoration industry's global watchdog, Pete. I know you have a couple quick comments here. We're running a little low on time, but I wanted to make sure I got you a chance to get in here.
Yeah, well, it was a real interesting interview, and I noticed that Ehsan, he proudly has that tiger paw on his shirt there. Yes, you know, I imagine if our Buckeye friend John Donnie happened to call in, of course, he's been so busy with the Siri business, he probably would have something to say about that. Hey, Ehsan, it's kind of interesting that you did some of your college work at the University of Nebraska. Of course, they're in the Big Ten now, but when I was a young kid, I have no idea why this is. I used to like the Cornhuskers when they were part of the Big Eight back in the day. It's the only conference that ever had the top 3 teams at the end of the season finished were all from the same conference. It was Nebraska, Oklahoma, and Colorado one year. A little bit of trivia, but I'll tell you, I went on a tour of when I went up to. Been up to Alaska a few times over the years, but the interesting tour, you take these tours to the Denali Park and you go on these school buses. And the one I went up with a friend of mine, one of the times I'm on there, it's in August, just before the football season opens. And I happened to be on a school bus. There's 45 people on the bus. 38 of them are from Omaha, and they were all crazy Nebraska fans back in the heyday. And they were really just unbelievably out of control. We had to be in this bus with them for like 8 hours. And at one point, about 4 hours in, the bus driver couldn't take it anymore. And he comes up with this little joke and he cracks. He says, you guys kind of were almost worse than those Texas Longhorns we had on here last week. He goes, the way I handled with them is, he said, you guys from Texas, if you don't stop this, he says, I'm going to tell you, he says, if Alaska split their state in half, Texas would be the 3rd largest state in the U.S. And he said that kind of shut him up. Everything may be big in Texas, but not compared to Alaska. I will tell you that something I like to comment on. I've as a lot of the viewers of the show, and certainly Cliff know, we're very interested in a lot of the academic research and a lot of the work with the universities. The restoration in particularly has a very strong connection to Purdue and their construction management program. And I know that Clemson has a similar one. There's a lot of schools in the Southeast that are like that. In Mississippi State, they apply for research, with the government and things of that nature. And one that Cliff and myself were involved with several years ago with some research that was done in Tuskegee, who got the contract. But in 2008, so here's the Clemson connection. We, Cliff and myself and a number of kind of an industry delegation from RAA and the IICRC. We went to a very special event hosted by Savannah Labs, one of the national labs, Savannah River National Lab, which happened to be in South Carolina too. And they hosted an event in Charleston. A couple of the keynote speakers were the mayors of
Mayor Riley.
Yeah, Mayor O'Reilly, long-term mayor of Charleston, and then the guy from the Gulf Shores. And they talked about resilience, and they talked about, their experiences coming through Katrina and a lot of these type of floods, and how to make the cities and communities resilient through research, through working with academia, through government contracting, and partnering with industry, how important it was. We had the opportunity to be there, report back to our associations, and kind of trying to build on that over the years. And coincidentally, I don't know, it's probably done now, but they were doing the restoration of the Hundley submarine, and we had a little tour with the whole group, and we, the association hosted a little hors d'oeuvres. We got a little PR out of it. But Clemson was very prominent in a lot of that work, and I was very familiar with a lot of the wind studies, the air stuff you're talking about, and all these things going through there in the building science. So it was interesting that Joe had you on the show. I talked to him yesterday, made a point of calling in today because I got a lot of calls, and it's very interesting. And I think that, the work that Joe's done for years down there and going down to Greenville and doing all that was really fantastic. So you're kind of like a part of the new generation of young guys who are involved in this stuff.
Yes, sir.
And I think it's really great. When the Healthy Building Summits kind of get back online again, maybe 2022, it'd be interesting to have young Ehsan be on there and kind of weigh in with his perspective as part of this research to practice and all that. But, I want to give a little bit of history. It just was interesting. It's a small world, and, as the more that things change, the more they kind of remain the same. We kind of find these roots. But, to pose a question to you, Ehsan, anything you can share with us in the audience, maybe Cliff could put in the blog, that's coming out of Clemson that is relevant to building resiliency from the damage restoration component, that you may be involved with, the university involved with, any pointers, any comment you got on that? Since I'm the restoration watchdog, I figure I should direct a question along those lines.
Yeah.
And anyway, just want to thank you, and very interesting. I'm looking forward to Cliff's blog. He's always fantastic as usual. And Radio Joe, there you go. That was a Pete 5.
Wow, that was good, Pete. Very good. Ehsan, any follow up to that?
Thank you so much. Thank you for sharing that history. It was quite interesting. And, it's like you said, world is a small place. It's just, I know that. So, let me give you a bit of technicality. I am technically part of a program or a department called Construction Science and Management. And then we have a department at Clemson, Civil Engineering. And I know for a fact that they do a lot of work along the lines that you just indicated on the resiliency, on actually preparedness, on post catastrophe and things like that. What I am interested in, and I have been trying to put that work together. I guess I'm always an optimistic person, so I have reasons to be optimistic about that as well. Is essentially if we can define COVID as a disaster, which is not flood, not hurricane, but it's a disaster. And our preparedness for that disaster entails a lot of different perspectives and comments, right? I would love to work on that. I have started leading a team, putting all that effort together at Clemson to define a research thread within those lines. And the idea here is to essentially look at air quality and then claim that potentially that can lead to a disaster that needs or begs a resiliency, both on the societal level and in the human environment level and in the built environment level, right? So this is the idea that we've been working together. Like I said, I have put a team together here, which is a well-rounded team. We have psychologists on board, we have optimization people on board, building scientists on board, computer scientists on board, because now you get to use a lot of the data that's out there to study something like that. And to me, resilience within those lines is huge. For instance, for Clemson University and Purdue as well, because I know actually they did really a fine job along those lines. And in the COVID era, essentially resiliency could mean, how do we get ready to reopen? How do we get ready to answer a lot of questions that are new, that just coming out of the how can we as a society, as a campus, as a college town indeed, right, be able to look at this together? I know Purdue did a lot of great things about that. Clemson also, Joe and I, when you were talking offline, we also, I also mentioned that we did a lot of things related to that here at Clemson. But it ought to be holistic, it ought to be systematic, and that's what research means to me. And I'm trying to do that. Hopefully, again, keep my fingers crossed. You always need money to do research. So we've put together proposals for the feds. Hopefully they find it interesting enough to give us money and we take it from there. But that's definitely 100% something on my personal agenda. That's something I want to do. I want to pursue.
Yeah. Hey, Joe, look,
Yes,
I got something really important now that Ehsan's comments triggered. And Cliff, I think it'd be good for you to put this in the blog. So Ehsan, I'm glad that you kind of mentioned Purdue and know a little bit about them. We've got long history with Purdue. Randy Rapp there, who's the professor, he just was named the named professorship for the reconstruction and demolition concentration under the BCM, the Building Construction Management. Now, here's why this is important in the context of the comments that you just made. They have, through Purdue and through our industry, a national connection with a fellow named Sam Bourouti, who is from the University of South Australia. There they call it the Built Environment School, which is equivalent to construction management. He was there for many years. He moved just across the way to the University of Adelaide. Same kind of work, same kind of deal. He's had visiting professorships here a handful of times, and after post-COVID, I think he's going to come back. And him and Randy have also done some published research in our industry on some topics related to this. Now, one of the things that I think would be good for you to do is Cliff and myself and a couple other industry bigwigs, Rusty Amarante with Belfour, he's been interviewed on the show. We were able to do a special panel presentation in 2000 and I guess 14 it was, that Purdue hosted a global infrastructure conference. There was the people there from, 8, 9 countries, all the countries that got affected by the tsunamis and all these kind of disasters. Mm-hmm. And the people that were there in the audience were essentially ones who worked for the governments, who advised the governments on the, global disaster management. And there's a document that we got published, was peer reviewed, and it was post-published, which is not the norm where you get a peer-reviewed paper part of the proceedings. They published a panel presentation, an industry panel. It's about 20 pages. It's on Purdue EPUBs. But quite frankly, if you go to the IAQA website, you search Randy Rapp, that whole department interview that Cliff, Joe, myself, we did on site with them. I think there's an access to download that document, which may be interesting to you and your colleagues. And there's a lot of information there that would be very helpful. And I could see something in the future, Joe, coming together where all these things are kind of collide, because this is what IAQA Radio does, man. We build these bridges for the greater good of all these industries that we connect. Because as a good young friend of ours up and coming said, Cliff and Joe, you guys are the OGs when it comes to this, because before anyone even knew what a podcast was, through TalkShoe, you all had the insights to do that. And even after all these days of doing a great job, and some of the people that call in every week on our call log right now are, just all leaders in their industries. And it's really good to see all that happen. So anyway, I wanted to weigh in. If Ehsan didn't say some of the stuff he did, I was done. But it's like you, Joe, once in a while, you have an audible. And you got to have the audible. Otherwise, what's the point of being a watchdog?
Buddy, I have no problem with audibles. Thank you, Pete. I want to say thanks to this week's guest, Ehsan Mousavi. Dr. Mousavi, thank you. That was wonderful. We're going to post the link to your Google Scholar page too. There was another paper on there we didn't get to, a few more. And I want to also make sure I thank Todd Usher, a mutual friend who got me in touch with you, and who's also down at Clemson, but also a builder in the Greenville, South Carolina area. Thanks for joining us. We really appreciate having you.
It was a pleasure. Thank you for having me on your show. It really was. I had a fun time, and I appreciate it. I thank you for it.
You're welcome, my friend. All right, this is Radio Joe Hughes saying thanks to this week's guest, Dr. Ehsan Mousavi. I want to thank my co-host, the Z-Man, Cliff Slotnick. John, you got to have faith at the controls. The restoration industry's global watchdog, Pete Consigli. Most importantly, our growing group of loyal listeners and sponsors. Next Friday, we will be back. We've got Dr. Mark Hernandez and John Lovett from Instascope. We're going to talk a lot about some of the work they're doing in schools and other areas. So come back next Friday for the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.